All right, we're going to get started. Welcome to NVO3, the second session. Today we have a shorter agenda. We've got 1 hour. We have two presentations. They are on a similar topic, which is OAM in overlays. So hopefully the two together can encourage a good discussion. Afterward, if we have extra time, which our agenda has, I think, 20 minutes for, we'll have some open discussion that we would like to focus on any questions around the data plane adoptions. We'll have time for that. If no one has anything to say on it, we can talk about other things or break up a few minutes early. So jumping through real fast the intro slides. First of all, as always, this is an IETF meeting, so anything you say here is a contribution to the IETF. The note well describes what that means in more detail, so please be sure to be familiar with it. We have blue sheets which have been started to be passed around. It's going to be, obviously, in a room this size, it's going to be tricky to get it everywhere, so I appreciate if people can help each other out, passing it around without too much distraction. We do want to get everyone's name on it if possible. We have John and Ignis, just as on Monday, are taking notes here today, so thank you both. We are presenting these through WebEx, so if you want to watch them on your screen or you're listening remotely, you can see them there. Today, like I said, shorter agenda, 1 hour long. We're going to hear first from Eric Nordmark and then from Diego Garcia about some OAM options. So I'll take one moment to see if anyone here wants to bash the agenda. And nobody's complaining, so I think, Eric, we can get started. What's that? Oh, yeah. Well, you can stand there. Come on.
Well, I'm supposed to stand here. Can we do some
video? I don't know that we're going to be on video right now, so I'd stand where you want.
Oh, you on the mic? There is a second camera over there. It's just the constraints of standing in the square. Particularly when you don't remember what you wrote on the slides, because you did the slides like a week ago. I was like, I don't know what's back there, but... So, traceroute for overlays. Go to the next slide. So there's three pieces here, and this is not an exclusion of anything else we might be doing with OAM, right? But this might actually be a useful tool in the OAM toolbox. So keep that in mind as we think about, different forms of OAM. One of my observations has been that traceroute on the internet today tells me a bunch of stuff that maybe I shouldn't be allowed to see, but I actually do see them, maybe for historical reasons, or maybe because it's actually useful, right? As we do overlay networks, we might actually lose some of this visibility by design as opposed to by policy. And this is actually not that hard to change, right? We have actually prototype stuff for VXLAN that does this stuff. So this is sort of the typical path that you could see. This was sitting at work. It looks similar from home. I have no idea what these routers are. So why is this useful, one might ask? Well, because I can take this stuff and put it in a trouble ticket, right? And I can send it off to our IT department, and they can go figure out, is the problem on our end, or is it as they go out to the ISP, or is it somewhere else? And they can forward this stuff along. And if I have a temporary outage, this is sort of the only way you can feed some useful information in, other than saying, I can't get there from here, right? So I think that being able to take this stuff and say, I can send this off, this is what I saw at 9 a.m. this morning, and someone can figure out, well, was there something wrong on this particular router at that point in time, as opposed to having to look everywhere, right? So that's the high-level thing. So today there isn't much policy to enable people to block here. If an ISP wants to hide their topology from this, from IP traceroute, they sort of have to either tunnel things, which they do with MPLS and whatever. I clearly can't see everything. I can't see the whatever optical trunks that are used underneath and whatever, right? MPLS, there's a bunch of things I can't see, but I can see a fair bit. I can see more than a binary didn't get there. And they could filter things out if they wanted as well, not send any ICMPs. Next. Oh, I have the clicker. When we come to tunnels, the IETF, if you go look at it, we have actually developed two different tunnel models. One is called the pipe model, and the other one is called the uniform model. This has been done both for diff serve as well as for TTL. And the pipe model is the one that's commonly used, right, or most commonly used. For NVO3, that means that the NVE actually puts on a fixed TTL that's configured in the outer header. And then on egress, you just throw that away. Oh, that's right. Oh, yeah. It doesn't really matter. We can do them in this order too, but okay. And with the uniform model, you basically are counting the TTL across the whole path, underlay and overlay together. And the behavior there is that the ingress NVE will set the outer TTL to be the inner or the original TTL -1, and likewise sort of copying in the other direction and decrementing on the egress. So these two behaviors are described, but people might mostly think about the pipe model. So some of the issues that actually show up that are particular to overlay networks, and in particular also to overlay networks carrying L2 or Ethernet frames, is that when you have a VXLAN type network, well, if I'm going from one host to another, they're on the same subnet, or the simple case of them being on the same subnet. When I do a ping and trace route, I see nothing because the packets don't go anywhere. There are no IP hops involved at all, right? And yeah, the ARP request may or may not time out. Depends whether you are propagating ARP information in the control plane or sort of doing flooding and whatever. But in order to see something, you actually need some access to the ingress NVE. So if I can get access to that thing, whether it's a virtual switch or whether it's a physical switch, I would actually need to do several things. One is check whether the underlay has an issue by doing a ping or trace route. But I also have to go check some set of tables that map my overlay traffic to the underlay and describe how they're sent, right? Whether it's mappings from VLANs to VNI IDs, whether it's some sort of flooding tables or whatever, MAC address to remote IP address of the NVE, right? I need to go inspect all of those things. And then I can tell, is this thing actually, well, that might not be sufficient because I'm not actually certain that the packet even reaches that NVE. And that's very hard to tell because it's effectively an L2 service, and you can't really, there's no widely available tools to tell that from a host. So if I don't have that access to the NVE, the only trouble ticket I can generate is saying it didn't work, right? And here's the IP address I tried to get to. So we have those two models. I guess it doesn't say that. So basically, this means that I can actually get visibility to underlay if I actually use the uniform tunnel model, because now ICMP errors TTL exceeded that traceroute uses will be sent from everyone along the path. Everybody will uniformly decrement TTL, the ingress and egress NVE included. But that's not sufficient. There's one more piece we need. It's about how we handle ICMP errors. And this is an area we've played in before, not for the TTL exceeded, but for other things. So the idea is that, so these ICMP errors sent by the underlay routers will be sent back to the source of that IP packet, right? Standard ICMP or IP forwarding behavior, and that's the ingress MVE. So the ingress MVE gets these IP packets, gets these ICMP errors, and it can go look inside and say, oh, this is a VXLAN, whatever, NVO3 NCAP packet that was in error. I can go extract where did it actually come from and send it back. Basically, deliver an ICMP error that makes sense for the original host. So if you actually look at an example of how this would behave is, and there's one special piece here which we haven't done before, which has to do with MAC addresses and MAC headers. But the first one, the host sends a packet with a TTL of 2. It gets encapsulated, and as part of that, the TTL gets decremented to 1. And then it comes to the first underlay router that decrements and checks TTL and says, this expired, right? And it sends back the number 3 here is the shape of that ICMP error. It has the NVO3, whatever, VXLAN header in there, and whatever it had inside, which is a MAC and IP header. And then when that packet comes back to the ingress MVE, it can form the ICMP error at the bottom that makes sense for the original host. And I don't know if I put examples of what this stuff looks like. Oh yeah, I have some examples. So that's all there is to it, right? Well, there is another one, which is you probably don't want this uniform TTL for all packets. So the host here says, I'm on the same subnet as this destination host. There could be some protocols that assume something about TTL, like TTL doesn't decrement. If I send it with TTL1, it gets there because we're on the same subnet. That would break if you applied this uniform model all the time. There could be other ones that use TTL255 and check at the receiver, same thing, right? So you have to do some ingress selection, or you have to do some selection at ingress to figure out, am I going to use the pipe model or the uniform model for this? And you could do that in any way you please, right? It could be based on, and here's where sort of the policy knob comes in, saying, should I do this for this customer? Is it for this port, this particular originating IP MAC address? Maybe I have some dedicated trace infrastructure that I run in the overlay for this, right? You can do anything you want. Something, if you want to do it at a granularity where a host can do it that is also running other traffic, you want something in the packet to select this. And there's two things that you can easily tweak in the packet and that you can set in the Linux trace route. One of them is the DSCP or toss byte, and the other one is the UDP source port that you use. So you can actually set up some things on the ingress MV saying, okay, this customer is authorized to do this, right? We're going to say that this customer can, if it uses this DSCP value or whatever, or this UDP source port, I'm going to give those packets the uniform TTL processing model. And there's some differences, there's some trade-offs in the draft between that in terms of entropy and whatever. I think I have just one slide left, so I think I'll go through that one before questions. But and the second piece is, if I want the behavior on the egress, I have to have some way of instructing the egress on a per packet basis. What TTL behavior do you want? And the easiest way of doing this stuff, we played around with different ones, but the easiest one is actually getting one bit in the header that says, please apply uniform TTL behavior at decap. And note that there's been discussions about sort of OEM bits with slightly different semantics, just to flag that it's not the same, right? The OEM bit that's been discussed is, this is an OEM frame that should not be delivered to the end host. That's not the behavior we want here. We just want this TTL behavior. Oh, yeah, there was one. You can do this with other ICMP errors. You can do it with ICMP packet to big, for instance. You can actually use it as a way of detecting that. I think my underlay should be configured to be able to carry the encapsulated packets, but maybe it's misconfigured. We've seen customers actually do this, right? And it's hard to find out. Well, not that hard. You send a small ping packet, things work. They run TCP and it doesn't. TCP times out because TCP sends full-size packets. Well, now you have to figure out, okay, what should I look for, right? And other sort of unreachables, whatever. So in VXLAN, we prototyped this stuff. We found a bit that, at least at the time, wasn't being used for something else. Don't know if that's still the case with all the VXLAN proposals, but and it basically says, here's the decapsulating behavior, right? That's all that bit, the semantics of that bit. And there are some things that might surprise people when you do this. So the first one is your underlay and overlay are actually different addressing realms, right? And you could think of this as separate verbs or whatever, but it's like, your customer has net 10, right? Well, you can actually run NVO3 or VXLAN, whatever, where the underlay uses net 10 as well. It's perfectly valid because it's L2 over L3. They don't meet anywhere. Well, when you do this, and that's not the example, but when you do this, the traceroute output is going to show the underlay and overlay IP addresses. So you better know that when you enable this thing, don't think that you can ping those underlay addresses in any useful way, right? But they might even be the same addresses that you use in your overlay in worst case, right? So as long as you know that, okay, I can do an overlay traceroute, which sees whatever overlay part of my path. I can do this combined traceroute that sees both. And if I take both of them and put them in the trouble ticket, someone can actually figure out what's going on. The other surprise is as you have different IP versions, this notion of getting an underlay ICMP error and generating an overlay ICMP error means taking IP addresses that are in the underlay and showing them in the overlay. Well, that works well if it's V6 over V4, because I can fit 32 bits in 128, which is what this example shows. There's basically V6 ICMP errors that have 96 bits of leading zeros or whatever. It's something. It doesn't really matter what it is. It's just something that provides useful information for the guy who's going to look at the trouble ticket. And I think that's it. Well, I guess the other thing is, I think that this is a useful tool, right? And it might be something that people should consider as they look at different encapsulations. So, questions?
Or comments. David Black. Let me relay something that I think was said rather strongly at the Spud or Spood BOF this morning. DSCP is not a signaling mechanism. Please don't use it for this. Actually, I actually think that your most common case, you actually don't need anything in the protocol, which is that if you're using a virtual switch that's co-located on the same box with your traffic source, that can be set up via other means. There's some interesting possibilities in figuring out how to make that one work.
Yeah, that's only one of the cases, right? But
yeah.
Also, you do need, if you want to do this at the granularity of a MAC address or an IP address, right? Basically, dedicate one of those in the overlay for doing the trace. It means that you sort of have to request people to allocate one of those for you, right? Whoever controls the address space for the overlay has to do that. And by putting a marker in the packet of some form, you are avoiding requesting that complexity.
Yeah.
Right?
I think keep looking, because this is not a good use of DSCP. Your discussion of how UDP affects ECMP, I think is fatal to use of the UDP source port, because all you need is one arm of a four-way ECMP to be out, and the OEM will never see it, and the traceroute goes through fine, but the traffic doesn't.
Yeah, but traceroute actually varies destination ports as well. So
if
you can't necessarily pick a particular one if you do that, right? But because of the varying destination ports, as long as that's included in the hash, right?
If you can get a traceroute tool that's prepared to keep retrying with a whole bunch of different ports and tell you which ones worked and which ones didn't, you might have a clue that something's wrong with ECMP down there. The other thing is just a warning, which we've had in the context of the NCAP discussion for routing, which is watch out for nested NCAPs. Sooner or later, you're going to run out of payload size in ICMP and not be able to rebuild what you want to rebuild without state in the NVE on the way back.
Yes, we have 512 or 576 bytes to play with, but yes.
Sorry, Sharon, the very bottom. I think what you're doing is a nice hack, but it's really architecturally wrong, because you are violating all the layers. Without terminating layer 2, you're just doing uniform pipe model. This is absolutely wrong.
Well,
I think it's a good hack, but it's
no, but there is a
architectural
question
wrong.
about what is the purpose of layers, right?
Yeah, I see
And
it's
one
a-
of them is providing sets of abstractions.
for that underlay.
But that
But-
doesn't mean that the abstraction should get in the way of visibility.
This is a one-hop underlay, whatever you want to, overlay. It's a one-hop overlay. Whatever you want to do is one-hop overlay.
No,
It's
no,
not
but
multiple
this
hops.
applies even when I have a combination of overlay and underlay hops, right? The same thing of being able to say, these packets are marked so that I can get
If you had
visibility
to-
to the underlay.
If you had terminated the layer 2 and have done an IP inside VXLAN, I would agree. But this is wrong.
Okay, it's an opinion.
Right, so, yeah, I was going to actually say something similar to him. Like, if you go to slide 7, right?
Do I have slide number, page? Oh,
This is Anup Ganwani from Dell. Sorry.
Yep.
I mentioned the name. So, you talk about the NVE encapsulating the packet after TTL decrement. So that's really not true, right? Because the NVE, if it's a layer 2 NVE, it doesn't decrement the TTL at all.
correct. That's one of the behaviors in terms of providing this uniform TTL model, right? That as NCAP and DCAP counts as hops there as well, in addition to the underlay hops, right? Because, and the reason I picked that one is that it seems useful to showing all parts of the path.
Right. So what if it's a non-IP packet that you're transporting over?
Well, how would you mark the non-IP packets, right? Yeah, clearly you can't find an IP header there to go do anything with, so
Right.
you'll just, you have to do the pipe model for non-IP packets.
Right.
But last time I checked, 99.9% of the packets that we carry here are IP, but it doesn't break those, right? That's the
Yeah.
key thing, right? That still works.
Still works, yeah. But
I know that this is different because people are used to thinking in layers, and that's useful for some things, right? But that doesn't mean if you make it significantly harder to see what's going on, and as a result making it operationally difficult to deal with these networks, I think we should pause, right, and think, is that really what we want, right?
I mean, yeah, the general thinking tends to be that you let the lower layers take care of themselves, and then you have someone that can query each layer.
Yes,
Layer
and I can see cases when you can say, well,
make the necessary correlations, assuming that they have.
but it is somewhat hard, I think, because I can see running even if I take, in some of the failures I've seen, right, even if I was running BFD, doing continuous monitoring of my underlay path, making sure that that one didn't fail, I still have configuration issues when this stuff fails. Because the mapping from L2 into the tunnel, right, is somehow misconfigured. Or whether it's, sort of the port comma VLAN to VNI or the flood list or whatever I used to do, right? That stuff is misconfigured. And those things, the underlay OEM doesn't help. I really need to connect and the overlay one by itself doesn't tell me anything other than it failed. And I don't have a good way of connecting the dots, right?
So if you had your end host sending out some kind of messages that looked like the data, they would go through the same data path and they would discover where the problem is, right?
It would just be dropped on the floor somewhere, right?
It'll get dropped somewhere, and because it's not received, you will know.
I know that they disappeared somewhere, yes. I could tell that it's not working, but I can't tell where it's not working.
So what you mentioned was that you're concerned about the place where the mapping takes place from L2
Yes.
to L3. And that mapping takes place at the ingress point
And egress, right?
and
Well,
at the egress. And so you would know.
but as you start more complex topologies, right, you might end up with multiple sort of chained NVO3 tunnels, right, going through some routers that route between them, whatever, and then it actually gets harder as well, right? Yes, I could give some idea about in the overlay, did it get to this router that, did it get over the first tunnel, right? I can tell that from the overlay trace route, but I then so now I know which tunnel to go debug. Anyhow.
So just a quick note, this conversation, we should move on to another
Yeah.
question and limit it to the people that are currently standing, just so that the next speaker hasn't as well.
Yeah.
Okay. So just one last thing.
Quick.
Yeah. So my biggest concern with this would be the scalability issues, because like, let's say you have 1 million VMs using the underlay. If each of those 1 million VMs tries to start doing things like trace routes that underlay needs to respond to, then how do you control something like that?
How do I control
That's the reason
today in an IP network? I don't know if it's any
you
different.
turn it off.
I block all ICMPs? No, I block all trace route? I can do it from home today, I can do it from here, I can do it from work. ICMP, trace route works in IP, and the routers don't fall over in the internet, and there's plenty of people that I'm sure are DOSing it right now as well, right? So I don't know if that's any worse, but that's...
Hi, Tom Herbert. So on one of your earlier slides, you mentioned these two models, the pipe model versus the uniform TTL model.
Yep.
So my question is, should we actually consider the uniform tunnel model as kind of the operational model? And the example I'll give, I think, is David's example. If I have two NVEs that are co-located with the host, with the VMs, TTL is irrelevant in that case. If they set a TTL of 1, that's one single tunnel, so therefore the packets will go. However, if my VMs introduce a routing loop in the overlay, then theoretically I can go through n squared hops in the underlay just to have one packet eventually run out of TTL. So I'm wondering if this is like a problem that we might want to address here.
But I don't think we can change it, because there are protocols like IPv6 neighbor discovery, right, that run between hosts that are in the same subnet, and they assume something about TTL. And the fact that we are building basically remote bridges using this overlay technology, that has to, for those packets to still work, it has to be default to being the pipe model.
Okay, so for a layer 2 network that might be true, but for layer 3, where we're offering a customer just a default route, the TTL could actually correspond to the underlay.
Yes, if you're not carrying L2 service over the NVO3 network, yes, that's correct.
So I'm just saying, maybe this is, I don't know, step number 13 in the 12-step program, but it might be.
Yeah, I think that's a good discussion to have, right? Which is separable from the how does this behave for L2, right?
Sorry, Sharon Devary again. So I want to give you one alternative solution, which is architecturally correct. So you can do, for example, Ethernet link trace route or link trace, and then that can trigger a IP trace route at the NVE, and then you can reply the results. That's architecturally correct.
Well, that's a different way of doing things. It's not a tool that people are used to today.
Yeah, then we can learn it.
Yes, and
so you want to twist the architecture and destroy all architecture soundness so that people are not used to it.
No, what is the purpose of architecture? Well, we should take this to the bar, but the purpose of architecture is not something that it's a way of organizing our thoughts and having ways of creating abstractions. It's not a way to forbid people from solving things.
It is. Architecture is a way of forbidding people to do insane things. It is a way of keeping everything sound and working in all different conditions and situations.
So we should continue this conversation, but not right now. There is one more question in the back, and I think we missed you as sort of a punishment for sitting in the back of the room.
Is the mic on? Yeah, the mic was not on earlier. So. In the previous session,
that's what you get, man. What do you?
So I wanted to add a couple more surprises.
That's Daryl, by the way.
We've had Daryl Lewis, sorry. We had a lot of experience with deployments with traceroute and L3 overlays, and a couple of the gotchas that we found in the operational internet are oftentimes we get much less than 500 bytes of data back. Like so, in the cross AF time expired coming back to the NVE, we get not enough.
Are you still seeing the only 8 bytes of the transport coming back?
Yeah, a lot of vendors.
Because we fixed That was added to router requirements in 1995.
I understand that this sometimes people
And we
don't
did that
listen
because
to
of
the
tunneling,
IETF.
right?
But I'm not pointing fingers because it's almost every vendor has a few, has a device out there that doesn't have. But what we found empirically
interesting, yeah.
is that when we do cross AF, oftentimes we don't get enough information back to determine the actual, IP address that we need to pass back to the host.
Okay.
So that's an additional surprise.
Yeah, it's very good. I was assuming that had gone away. but
Yeah,
okay.
and then the second surprise, well, I mean, that Windows and stuff doesn't use UDP for this, and it's a real struggle when the tracer client itself doesn't understand the cross-AF information you're passing back. So a lot of times you get stars and stars and stars, where you really wish you could get better information back to your users. And then I think the other thing is that there was a lot of comments about performance and stuff in here. We've shown in implementations that are doing this that do a small cache just for traceroute on the encapsulator or decapsulator that handles its functions. And if it's just a small buffer, and if it overflows because too many people are doing it, then people get more stars than they would have gotten otherwise. But it hasn't impacted the NVE performance on the control plane.
Are you saying that they remember the traceroute packets?
Well,
I mean, they don't.
you have to identify the trace route that's coming from the host, right? And you have to know when you get packets back to the NVE where to send the trace route back. This is L3 that I'm talking about.
No, not when you get the whole payload, right? Yes, if you only are getting 8 bytes back, sure, right?
Exactly. So
Okay.
you got to figure out a way to hack this. But what I'm assuring you is that hacks can be done without compromising the performance of the NVE. And the final thing that I'll mention is that forgot. Doesn't matter. All right. Bye-bye.
Okay.
Thank you.
That's useful. Thank you.
Thanks, Eric. Diego, you can use this to...
Hi. So what we're presenting is a bit complementary to what Eric has been doing. It's OEM from the NVE to the NVE to do a bit of data.
Be sure to... You can take it off if you want, but be sure to...
Yeah. So basically the idea is to have the capability of doing traceroute and OEM from NVE to NVE. And some of the things that we wanted to cover with the generic overlay was having, the first point, what Eric mentioned, that indeed existing ping and traceroute does not work very well for overlays for the reasons explained before. But some of the things you want to verify is, yes, how do I find information from the underlay? How do I find information from the path that the packets are taking? How do I verify the behavior of the network when there's ECMP and multiple paths of ECMP in the way? How do I deal with consistency of the control and data plane programming, especially when we're talking about an NVE that might be co-located with the server in the hypervisor, but the controller might be an OpenFlow controller or some external controller. You have to have some way of ensuring that that data path that you believe in BGP is one thing, has it been reflected down to the forwarding plane. Have some way of doing continuity checks, fault verification, some fault isolation as well, and performance in terms of delay and packet loss measurements. So in terms of the requirements for the overlay framework, what we wanted to do is have the overlay endpoint should be able to send some form of frame that follows the same data path and reaches the end system, reaches the end NVE, but at the same time somehow doesn't get accidentally leaked to the VM or to the end device that is behind the NVE. I think, while it might be acceptable in some production environments where every so often your OEM packet actually reaches the VM that you were trying to target, we're trying to avoid that as much as possible. And then by that means it's the endpoint should be able to differentiate what's an OEM packet and what's not, so that it can parse it appropriately and reply back to the originator so that we have some information. And the idea is that we are able to achieve OEM for both applications in the layer 2 and layer 3 overlays. We're seeing that NVO3 is moving to supporting not just layer 2, but towards also distributed virtual routing. environment. So, trying to build the OAM in a way that supports both mechanisms. And again, the other part is the fact that we could have some capability for doing trace path, maybe not necessarily from the client endpoint, and in fact, we're not looking at it from the client endpoint, but rather from a central management system or the NVE itself. As a network administrator, I'm able to look at how I am going to be able to find the path that the packets are following, find if there's one dead link in an ECMP bundle or in an ECMP fabric. How do I find that particular link that is being troublesome? And sometimes you could forward packets based on purely on, you can try from an NVE to another NVE using ping or some direct underlay test, but you're still not fully verifying that your VXLAN encapsulated packets are making it through, that indeed the endpoint is properly configured. And part of what we're doing also with this framework is the idea is that to support multiple overlay technologies. So, not just VXLAN, but NVGRE, MPLS over GRE, MPLS over UDP, and some of the upcoming encapsulations are being proposed as well. So, try to be generic so that we can, not be the universal panacea, but having some way of having something that is covering the different use cases that NVO3 is looking at. So in terms of the packet that we were proposing is, this is very similar or similar to what was being done in some of the LSP trace routes and LSP OEM that was previously specified in MPLS. And we were looking, compared to what was presented some time ago in a previous IETF meeting in terms of versions, we actually added a version header to the packet itself so that we could support multiple evolving formats for the packet. And you'll notice that there are timestamps and sequence numbers very early on in the packet, and this is to, as much as possible, have the capability of doing hardware timestamping in the platforms that will eventually support it. We tried not to do the timestamps as TLVs randomly in the packet, but rather in a fixed position, so that if a hardware implementation could potentially timestamp it directly and not have to look at it and punt it to a control plane, to a supervisor. So, and then what we added is some TLV formats for the type of encapsulation that we're trying to OEM, and optional TLVs to identify the end system. So if we're trying to figure out what's going on with a destination MAC address. So there are two parts of the draft. One is verifying the tunnel from an NVE to an NVE, so from VTEP to VTEP. And the other one is, okay, also once I get to the destination, can I try to find certain information about a particular endpoint, a particular host that I'm trying to reach, and I might not be having the visibility to get there. So in terms of the overlay ping, in terms of how do we originate and detect this OEM packet, the idea was to have use some form of router alert bit in the VXLAN header. And I'm not particularly set on it being one particular bit. We had a proposal and we have a draft implementation based on that, but there's been on VXLAN GPE, there's its own OAM bit being defined. We could coexist with that bit and just use it, look at the interpretation of how that bit would be used. MPLS over GRE or MPLS over DP, we could do a router alert label that would keep things clean in that encapsulation. And in the inner header encapsulation, here is where it gets a bit trickier or a bit different. For everything that's tunnel-to-tunnel verification, so VTEP to VTEP verification, the idea is to actually have a full VXLAN compatible frame, so it has to be at least an Ethernet header. And we were looking at doing actually an IP plus UDP headers as well. But the echo request and should have a destination MAC address that's like a well-known MAC address that we can trap, and we can prevent, in case this OEM packet arrives to an NVE that doesn't know how to interpret the router alert bit, then we don't want that packet to be forwarded to the end host. So we don't want to have it, we don't want to cause that packet to be flooded or so on, so we're trying to use one of the slow protocols MAC addresses so that we can actually trap it. And the same thing with the IP address. If there's any chance that this packet would be routed, we're using a 127.0.0.0 or, a local host address so that we don't send the packet accidentally to anyone. And this would allow us to properly identify the packet as destined to the VTEP itself, so that we can get an idea of how trap it and send a response back to the host. And in terms of a layer 3 overlay, the encapsulation would be similar, except we wouldn't be adding that additional inner Ethernet header with a MAC address reserved from IANA. So, yeah, in terms of, again, the packet information, we had a couple of side drafts specifying the router alert bit in NVGRE and VXLAN. We had the MAC address as being requested, and we had validate the control plane and data plane, the echo reply with the return code. So this is the encapsulation for the reply, the same idea, again, similar MAC address, similar destination IP address, and so on. And we would have different return codes in the packet so that we can able to look at what the different possibilities of errors, the different error types, different error codes were. So the type of request that we're looking at in the moment is basically an echo request and an echo reply. The echo request could also be used to perform a trace route as well, and we'll see how that works. And the reply mode, there will be a no reply, so we can specify the type of reply that we want, and we could specify do not reply mode, so meaning we're just sending probes that somehow the receiver will keep statistics, will measure, like they have a sequence number, so you can measure gaps in the sequence number to determine random packet loss or estimate packet loss. Or you could do a reply via a routed IPv4 packet or IPv6 packet back, so not encapsulated into VXLAN, just routed back to the originator. Or you could reply via the overlay segment in the return path via the return tunnel, if the return tunnel is available. So sometimes this having the possibility of having two reply modes gives you the chance that maybe your outgoing tunnel is working, but the response tunnel is failing, so you can send the response to come back through a routed infrastructure, not tunneled, so you can see, okay, I'm seeing that my unidirectional path is working, but my return path is the one that's failing. So having that possibility opens up some, slightly more interesting troubleshooting options. And yeah, we have a couple of return codes as well. And for the path trace procedure, I mean, the idea is to be able to send the echo request with outer TTL. Again, this is originated from the VTEP or the NVE, so we have direct control over the TTL. We're not doing layer crossing there, but we would be setting the outer TTL to a particular value, and we're able to send the packet back and forth. And for every increment, we could also randomly or sequentially increment the source UDP port so that you can exercise a certain number of hashes for your ECMP fabric. I don't guarantee that we're going to discover every possible ECMP path, but if the user could request that for every TTL increment, I send 16 different UDP values, and then I increment once, I send 16 more values, and so on. So you can get a good idea of sweeping the underlay. And the response for the TTL expires there would be, again, dependent on part of the ICMP response. It's interesting to see the point mentioned before that, yes, there are some implementations out there still replying with only 8 bits, so 8 bytes. So we have to see, how much information can we glean from 8 bytes. If the 512 bytes or 500 and so bytes were available, that's, it's easy to determine the whole thing. But with only 8 bytes, we'll have to see how we can do that. But there's, short of also requiring the intermediate transit nodes to implement some version of this OAM, which potentially they could do in later steps, the relying on the ICMP time exceeded message, it's whatever we can have today. And basically, in terms of the other part is, not just verifying the tunnels, but verifying the end systems. And what we specified there were a couple of different TLVs where we request to ping or to verify the forwarding tables for a particular MAC address, MAC IP combination, or just a raw packet that we specify as a certain number of bytes. So in that case, the idea is that we are able to look up against the layer 2 tables, or the routing tables of the end NVE, and we are able to get a response of whether that MAC address exists at all in the NVE that we send the request to. And again, we have a couple of requests, but yeah, basically the next steps are, looking forward to comments and feedback. So we already got some comments on the mailing list and in person today, but we're looking at working at that.
This is Sharon, the very Broadcom. This is another architecturally wrong proposal, and I'll tell you why. Why do we even need the OEM for overlay? Overlay is an adaptation layer. You're not going to forward based on overlay. Just put an overlay VXLAN header. Can you forward this packet? You cannot. It's like you say, I want an OEM for ether type. This is an adaptation layer. VXLAN encapsulates your L2 header into an IP packet. That's it. Why do you need an OEM for the overlay?
I mean, there's pretty much...
What do you want to detect in the overlay? In the VXLAN, what error do you want to detect in the VXLAN?
Is the tunnel working at all or
yeah,
not?
but tunnel is not, VXLAN is not the tunnel. The tunnel is IP.
I'm not sure I follow. I mean,
you cannot forward the packet based on VXLAN header. Okay.
I think this is the same point as before. So when I was standing up there and you said that this is wrong, like, I guess I didn't quite understand what this was. But as far as I can tell, what you're arguing is that everything that has to do with the uniform model is wrong. Yes, because the uniform model says something about TTL behavior. And you're arguing, as far as I can tell, that is architecturally incorrect, impure, whatever. And we've had standards doing this stuff for MPLS, for IPv4 over IPv6, for a number of things, for decades.
Maybe I put it this way. What can you do here that you cannot do with Ethernet OEM and IP OEM that we have? What can you do here that's extra to that?
I mean, with
I think
Ethernet...
whatever you want to do here, you can do it with Ethernet OEM for the overlay and with IP OEM for the underlay.
This is why you want OEM, because an NVE might encapsulate to two or more NVs on the other end. And while it's encapsulating to it, it wants to test to see if this encapsulation path is up. And if it goes down, it wants to switch. That's why you need OEM packets to be originated by the NVE.
You can say not originated by NVE. You can originate by NVE. So you just want to test check the mapping from the... basically, you want to check the correct VXLAN header is added. That's what you want to check.
You're testing the path from the input NVE.
So, yeah, but you can do it with
You're testing the path from the encapsulating NVE to the decapsulating NVE, and the packets are being originated there. So you can
But you can do it with the IP.
So I think we should probably, this is a specific discussion we should have. There's something fundamental here around who gets to do troubleshooting, if it's the tenant system, this keeps fading in and out, tenant system, or just the NVE owner. I think maybe we should start from the point of view of what we want to facilitate and then talk about the architecture.
So to that line, I have a couple of comments. Daryl Lewis, a couple of comments about this. First of all, having done a lot of over the internet overlay troubleshooting over the last 6-7 years, I'll tell you that it's absolutely essential that you use the same UDP destination port that you're using for data packets when you try and decide if something's alive or not in your ping, because very many times there'll be a middle box that's blocking some port but not another, and
Yeah,
you're really in trouble.
So we are using exactly the same UDP port as...
I misread the slides.
No, there's an inner UDP port transported all the way inside the overlay that could be, but the outer VXLAN is definitely the same.
Okay.
We're not touching
And the
that.
second point is that I have to congratulate you of using a union of every idea when it comes to troubleshooting that I've ever seen. But I will say this, that one of the other problems with operationally is that if the tool that you're trying to troubleshoot with is broken or somehow it's so complicated it wasn't implemented properly, you're really stuck. And so I encourage you to find a very simple, small subset of this, get some operational feedback, and then add to it over time.
Yeah, so that's the other thing that we were looking at after some of the conversations we had these days, was to split it into one thing that's verifying purely the tunnels and the other is end systems. But
So last comment.
Yeah, so a clarifying question, Eric Nordmark. So you said you have this router alert or OEM bit. So does it have exactly the same semantics as in the GPE draft, or do you know?
As far as I read from the GPE draft, I could understand the idea is that it's a packet. I mean, it means it gets punted to control plane and interpreted.
In particular, in the GPE draft, it means that it never gets forwarded to the end system, right? Is that the semantics?
Yeah, so that's my idea. I don't want that packet to be forwarded. The thing is, I cannot guarantee that it will happen for in pure VXLAN, that it will not happen for non-router alert bits aware implementation. So.
Sharon, the mic's off. I'm going to actually, but I'm sorry, I'm actually going to cut the conversation on this topic. It seems like there's a lot of good conversation that's happened and a lot more that we need. So we'll get together with a few of you after this session to chat more about what the next step would look like. But everyone should please read these drafts and comment on the mailing list. So thank you.
Thank you.
So we have, and I'm sorry, I am really sorry to cut that conversation short, but we have about 10 minutes, a little less than that, left before we're supposed to be done here. And I wanted to make sure there was a chance for some open discussion of the data plane adoption that is in process right now. If no one has comments on it, we could break up early. If you have any comments, questions, or whatever, this is a chance to speak about it for a few minutes. And just as a reminder, we are in the process of adopting, we have 3 calls for adoption out right now for the VXLAN GPE, for GU, and for the, why am I forgetting the name of the last one? Genève. Where's Jesse? He can, yeah.
I call it Genève. We need a pronunciation guide, but okay. Yeah. Do we pronounce it in French? I mean, there's like beer, the beer working group that's pronounced in German, right? So, yeah, then there's food as well, which. Okay. So, I guess sort of there's this sort of balance between industry and the IETF. Right? I think it would be good if we could. The ideal thing would be if we could come up with one encapsulation, right? But not sure that how that would actually happen. And even if we do, we still have things that is getting deployed out there, like the basic VXLAN stuff. So I don't know if it's useful to think about whether the participants here and sort of wearing a combination of their IETF hat and their sort of, we're deploying this anyhow hat, which happens out in the real world, sort of are amenable to thinking about, are there ways that we could prune things down a bit and not end up with sort of these 3 potentially being deployed plus whatever things are out there existing. And one thing that might help with this stuff is sort of looking at the encapsulations considerations thing. And there's some thoughts about extensibility. There's some other things about how do you encode extensibility in the packet so that we can make it a bit more future-proof if people want to build hardware that can use the extensibility mechanisms, which, the encapsulation, the design team that was looking at this stuff actually came up with some good things that we wrote down, which seemed to sort of point out that unconstrained TLDs are actually very hard to deal with in hardware. Sure, the encapsulations, all of them have the ability to say, we can skip the whole thing, right? We can pass over these extensions, but if you in the future say, well, there's some security extensions that are useful, it would be useful to be able to have the hardware actually parse and insert and actually do something useful with those. And if people, I don't know if people have already looked at that stuff and say, here's something that would make me tweak my encapsulation, and if people are willing to do that, we might be able to get fewer of them. But I mean, I don't have a problem with the working group adopting these things and sort of refining them, but I'm thinking about what is the world going to look like 3 years from now, right? Or 5 years from now, or whatever, right? How many of these things are going to be deployed out there? That's my real concern. And I want to make sure that the IETF is part of this conversation as opposed to being completely sidelined because people deploy whatever they want and we don't get the benefit of sort of the additional review and sort of broader thinking in the IETF.
Yeah, thank you. So just to respond, I guess I see this as a process. If it works well, we want to adopt and document things that are going to be deployed and or are deployed. Now, at some point, we could do more than that. We could maybe come up with one of them that we think is going to be the must implement standard, or perhaps there's a way to combine ideas or whatever. I'm not going to prejudice what the outcome would be, but I think trying to balance out this, recognizing that people are going to deploy things and we need to document it on one hand, versus it'd be nice to kind of come together more coherently and help the community on the other. I think I agree with your point, and I think that's a path we're going to try to walk. Any other?
So I actually just wanted, this is Jesse, I just wanted to follow up on one specific point that Eric made, not so much on the general process, just as far as the unconstrained TLVs things. So I actually happen to know, I think 5 implementations of Genève at this point in commercial switching silicon in the multi-terabit range, including parsing TLVs. So I just wanted to kind of challenge the conventional IETF wisdom a little bit, just throw that out there.
Sharon, context team. So it seems like we give up on one encapsulation because there's a new one, a new encoding or encapsulation every few weeks or months. But at least define a mechanism to negotiate which encapsulation is used by the 2 NVEs. That would be a start. And one small comment to Eric and the OEM, the other one, about traceroute is overlays inherently support multi-homing, so that I didn't see any addressing in that. So there may be multiple ways to get to the same in the overlay.
Let's keep the conversation on mic if we can.
So to add to Sharon's comment.
That's Dino.
This is Dino, sorry. In the list working group, we added an encapsulation type format to the mapping database, and right now it's enumerating 7 different encapsulations and growing. So just to let you know that the mapping database could tell you what VTEP address to use as well as what encapsulation. So it's a form of negotiation, not back and forth, just what I will support and you pick one of the ones that you want to encapsulate to.
Yeah, so just sort of add to that, that means that the control plane has multiple data plane options as a requirement, right?
This is Elango from Intel. I think I want to make the same comment that I made at the virtual interim as well. Now trying to come up with one single encapsulation format that's a standard from IETF is not going to help the industry, because you already have many different and you're going to create one more that the industry may or may not adopt. So you're creating more problems than solving it. Where it might be useful is in the TLVs, where still it's in the early stage, where it's possible there where the IETF can come and define some TLVs that are useful for maybe future hardware to parse it, as Eric was saying. And so this is a good time to start have that conversation and define some TLVs that could be adopted as a standard within the IETF.
Just to clarify, you mean maybe using the same TLVs across different protocols?
That's correct. So if you look at the TLV format, I mean, at least between 2 different protocols, I can see that it follows exactly the same format. So you can always go and standardize the TLV, even though the outer encapsulation that carries the TLVs might be different. You can still standardize a TLV format that could be useful in future. And it could, I mean, you can get interoperability as well. You can make them work together, and also you can make the hardware that parses it to interpret it correctly or consistently across the encapsulations.
Yeah. So thank you. We'll take the 2 people that are standing here, and then but I have to close the queues because we actually really do have to quit on time today. The plenary's in here next. But before we go on, Tom, who has the blue sheets, and more importantly, if you haven't signed the blue sheets, please find them and do so. Sorry, go ahead.
Tom Herbert, so I just wanted to comment on that. So one thing we are doing in GU is actually defining several extensions. So we have a fragmentation extension coming up. We have a header checksum and a few others. Security is actually very important. And I think most of those could be generic. So for instance, if you wanted to apply those to TLVs, right now they're in flag fields. So we can actually somehow separate out the base encapsulation from how you extend the protocol and say that, for instance, TLVs is one mechanism, flag fields would be another. But the content of those may be either the same or very similar, and that could be another common point.
Eric Nordmark, also a quick response to along with that. Yeah, I think that's a good idea to think about things that are common in terms of, I guess, not necessarily TLV encoding, but the actual payload and its semantics, right? And it ties in very well with one of the observations that was made in the NCAPS design team, which is that the times when we have defined these sort of extensions and haven't actually used them, right, they've sort of have become useless. That it didn't get implemented in hardware, or the middle boxes just drop it on the floor or whatever, right? So maybe there's some sweet spot, whether it's some security cookie or something, right, that people might want, where they want sort of better protection against packet injection, that we could sort of say, okay, here's a starting point, let's pick this one, and we define whatever, how big it is, right? And then if that helps sort of get across the hump that we have some hardware support for something, that we can get into NICs and switches, right? And then we can see, well, to the extent it needs to be in NICs, but maybe that just pass it to software. But then we can, that might actually help in terms of ensuring that this is likely to be useful down the road, right? Extensibility mechanism.
Thank you for the comments, everyone. Obviously, we have actually the beginning of some good conversations here on these two topics. So please don't lose the energy. Let's take this to the mailing list and the hallway, and I appreciate it. We'll see everybody soon. We'll announce an interim meeting at some point, another virtual interim meeting, and you'll see some of the details on the mailing list. So thank you. And I see one blue sheet coming up here. If you haven't signed it, please come up to the front and sign it. There's another one over there. All right. Thank you, everyone. There's one on the clipboard.